All right, so almost always when you have Ohm's law, then there's another equation, I'll skip this, called the power equation. And so that looks like this. So what you do is you multiply the current times the voltage, and so the current is in amps, the voltage is in volts, and that gives you the units of power, which are the same units anyway as the units for mechanical power, and that is of course watts. Alright, so let's see. And then of course there's, if you wanted to, once you know how much power you're using, and you want to want to know what the cost is, you use well, here, let me explain. So let's say you were using, I don't know, a 100-watt light bulb, and you used it for so many hours. The reason that I use hours here, so time is in hours, is because this rate is what the power company charges you. And so the power company charges in what they call kilowatt hours. And that's just, like, for example, in Rock Hill, and in the Southeast in general, the power company, usually charges about 10 cents, so 0.1 dollars per kilowatt hour, and that's a pretty typical amount. In California, for example, it's much higher. They have higher taxes and things like that. Okay, so we'll do an example of this power, and this one's pretty simple. There's a simple example that you do. You divide the whole thing by 1,000 to figure it out. I'll try to remember to do an example of this, but there's one in the book. It's pretty simple. All right, so we'll turn to the power equation. So here we go. The power is equal to the, oops. Wait, let's try that again. Sorry about that, I was going back to mechanics. Power is, of course, the current, for electrical power, the current times the voltage. Okay, so again, the units here, the power is in watts, so it's capital W. The current is, as it always is, in amps, and the voltage is in volts. And so an amp times a volt gives you 1 watt of power. Oops. Alright, so let's say we had a resistance of 5 mega ohms. No, not 5, so let's say 5 kilo ohms. Keep our lives simple. And we had a volt, or yeah, let's go with voltage. Let's say we had a voltage of 250 volts. Alright, so 250 volts. And I want to know what the power is. Okay, so the question is, how much power is being used by that device? Well, you can't really do it right with just this information. So what we're going to have to do is we're going to rely, as you usually do with these kind of problems, is we're going to need Ohm's law first. So Ohm's law will give us what the current is, right? Because the current is going to be the voltage divided by the resistance. Resistance, that's supposed to be an R. Alright, and let's see. So now notice this resistance again is in kilo ohms. It's got to be in ohms, not kilo ohms. So we're going to have to change to our metric using our metric prefixes. So this is 250 volts divided by, kilo is times 10 to the third, or you could just write 5,000, which is exactly the same thing. 5,000 ohms. Okay, and let's figure that out. So when you do this, the resistance, I'm sorry, the current that we're solving for turns out to be 0.0 let's see, what do I have on my calculator? 0.5. And that's, of course, amps. Oops, that's supposed to be a 5. Alright, so now we know the current, and we can figure out the power, because the power, of course, is the current times the voltage. See, we already know the voltage, 250, but we've just calculated the current. Alright, and so it's really just 0.05 times 250, so here, I'll do that down here. So our power is 0.05 amperes, or amps, times 250 volts. And so let's get my calculator. Alright, so the answer turns out to be 12.5 watts. Let's suppose that there was, I'm just going to expand on this just a little bit. Let's say that there was a part B to this problem. Let's say this part was part A. And in part B, they want to know the power, but now they want to know the power in horsepower. Okay, so what's the power in horsepower? And this works the same way it does in mechanics, right? Remember, in mechanics, 1 HP, 1 horsepower, 1 HP is 746. That's not looking very good. 746 watts. And so we can just use that as our conversion factor for part B. We take our 12.5 watts, and we just say, well, in 1 HP there is 746, that's supposed to be a 7, watts. And of course the watts cancel, and when you do that, I think I've already done it in my calculator. Yeah, I did. Let's see, so it's going to turn out to be 0.01, I'll round it to 7, 0.017 HP, right, horsepower. Right, so that's a very small amount of horsepower. Okay, so there's some examples like that in the textbook. So all right, let's do an example with this cost. You have a homework question that has you do this, and so let's look at that and do a good example. And so here's what it looks like. So you have the cost of running some device that uses some number of watts. All right, so let's start off with that. Let's say we had a 100-watt light bulb. Okay, so we know the power is 100 watts, and the time has to be in hours here in this equation. So let's say we had a time. Let's do it for 24 hours. Let's try that. 24 hours. So you're leaving a 100-watt light bulb. Suppose you're leaving your home or something, and you're going to leave a 100-watt light bulb on for the whole day. Let's say the power company charges us a rate, and this is the kind of stuff that's all given to you, and you just plug it into this formula above here. So let's say the rate is, I'm going to make it really cheap, or relatively cheap. Let's say 8 cents. So 8 cents is $0.08 per what's called a kilowatt hour, and that's actually a unit that the power company uses. A kilowatt hour is actually a unit of energy. That, by the way, answers one of your homework questions, because remember, watts are work per unit time, and then it's multiplied by a unit of time, and that changes it back to a certain amount of work or energy. So it's not in the proper units that we would normally use, but all right. So anyhow, we're just multiplying all these things and then dividing by 1,000, and so here's the cost of running this thing for 24 hours. Is going to be, let's see, so it's going to be 100 watts times 24 hours, all right, and then times 0.08 8 cents per kilowatt hour, and then we divide the whole thing. I didn't put all the units there, but let's see, per kilowatt hour. Sorry, that's getting all scrunched up. And then you divide the whole thing by 1,000, and that gets rid of the kilowatts, by the way. That's what that's for. And so this comes out to be, let me get my calculator. So with my calculator, I get 0.192. Of course, that's, you know, dollars. I guess I should put the dollar sign. And so it's basically roughly 19 cents to leave that 100-watt light bulb on all day long. If you're being charged at a rate of 8 cents per kilowatt hour, it would cost you 19 cents. There's the 19 part for every single day that you used, that you left it on. You know, and so if you left it on 5 days, the cost would be 5 times 19, right? So, or I guess technically 19.2 cents. All right, so that's that example.